Welcome everybody to the React Meetup online of this week. My name is Daniel Marin and I'm a software engineer at this.labs. First, I want to remind everybody that our sponsor today is this.labs, your partners in modern digital transformation. We specialize in mentorship, consulting, training, and staff augmentation for enterprise organizations. Find out more at this.labs.com or send us an email at hi@this.co. So we had a lot of announcements. We have a lot of going on this month. If you're not aware, we're running today our modern WebKC. It's going to be online in this case, given the global situation. We're going to have also the GraphQL fireside chat. We're having a view online, state of view. A lot of people is waiting for this one. If you're an Angular developer, we're having the state of NGRX also. It's coming soon in May. And finally, we're having another session of this React Meetup online. We're going to be talking about the state of React. So stay tuned. And also, just to highlight, we're also doing this month the JavaScript marathon training. And if you want to learn more about React, we have 2 more free sessions. One is an introduction to Netlify with React. And then we're going to be talking about using GraphQL with React. With nothing more to add, our speakers for today are Pablo Nevares, engineering team lead at Carvana, and Erik Rasmussen, founder of FormNerd. So let's see our today's schedule. Well, I'm just giving you a welcome, and then we're gonna give the stage to Pablo, that's gonna be talking about Microfrontends, smaller, faster, and stronger. And then we're gonna head up to Erik Rasmussen, which is gonna be talking about modern forms in React. So thank you, and I leave it up to you, Pablo.
So like Daniel said, my talk is going to be about microfrontends. Some of you may be familiar with the concept. I spent the last few years working at various times on different microfrontends, and I have a sort of introduction to the idea. I have some pros and cons, and then some details about my personal experience with examples and some takeaways at the end. So that's the overview I just gave. Also, there's a few different options available to use today that I'll cover. So like Daniel mentioned, I'm an engineering team lead at Carvana. I work on the customer experience team developing an internal tools platform. And I specialize in the user interface part of that platform, which is relevant to React here. A quick introduction to a micro front end. There's a little bit of a history I'm going back here when, back in the day when web pages were deployed manually on FTP, and you used to have, the separate files on like maybe you had source control, but you would send them to a server to deploy. The builds were small. They weren't really builds. You were just FTPing individual files, and hopefully you grabbed all the files necessary to deploy a version. The next phase of it was dynamic web applications, maybe using Java, PHP, but they introduced larger deploys because you deploy the entire application, right? There was an ecosystem that worked together, and there was more code than before, right? There was actually an application that dynamically connected to a database and that kind of thing. And then single page applications amplified that trend. Suddenly we had a SPA that you'd have to have a bundle with Webpack or Grunt or Gulp that you deploy, and it was a monolithic deployment, right? You deploy the whole thing or nothing at all. But your web app, especially today, probably isn't really a single page application, but it still uses a lot of that same tooling. We still use, especially if you use something like Create React App, there's everything shoved in there that you might need. But a micro front end tries to take it a step back and say you can separate your application at the natural seams within that application, either physically in the browser, maybe a header, a sidebar, and a body, or maybe on domains like users and something like Twitter, you'd say tweets, profiles, profile editing, that kind of thing. And you still maintain independent development, but you also recognize that you do have dependencies on other systems. So a micro front end wants to separate from the monolith, but also acknowledges that it needs parts of that usually to work. There's a lot of hot takes on the internet right now about micro front ends. This is just from earlier this week, I guess, that maybe if this is your first time hearing about it, you're surprised that people are over micro front ends. And I'd say for different uses, it may not make sense. And for some, it does. And I'll cover some of that throughout the talk. And at the end of the summary, I'll acknowledge that as well. But I want to talk a little bit about the trade-offs. So I'll call it monolithic applications versus microfrontends. I don't mean monolith as a dig at that style. There's a name for it, and I'll give it that. So with a monolithic application, you have initial velocity, but you're sacrificing, in my mind, a lot of the long-term velocity. As an application gets bigger, it becomes harder to develop within it because you have to understand all the interactions within it. And with a micro front end, you have slow velocity at the beginning because you may have to set up a micro front end, especially if you're rolling your own. But you have long tail velocity because the application, the micro front end application, has a scope to it that is much smaller than all of its parts put together. You also, in a monolith, you have internal complexity, systems that interact with other systems. And in a micro front end, you have external complexity where it's not a part of the project, but you have to play nicely. You have to follow not just API contracts, but also contracts between handoffs between two different user interfaces. In a monolith, you tightly couple within that application, but in micro front end, you loosely couple between them, meaning that those applications can make changes as long as they don't violate those contracts, that you can maintain a running application and maybe not have to deploy it for weeks, months, as long as nothing changes on either end. And then I'd characterize a monolith as you have to roll back an entire release. And while that's true with a micro front end, the releases are much smaller. I think they have to be much smaller because you're rolling back the only change that was necessary for that slice of your application. And then I think that is probably the next bullet is also saying the same thing. You deploy everything in a monolith. If you just change one character in the application, you have to deploy the entire application generally. And in a micro front end, you just deploy what changed. You just deploy let's say the example of Twitter, you deploy the thing that updates user settings, not the tweet view, not the home view, not other applications within that. And then the last one is, I think, probably in my mind, the most important trade-off. With a monolith, you have synchronized dependencies. If we have 7 teams working in one project, and one team needs something, a gigantic NPM module, right? People like to throw shade at Moment. So let's say Moment.js. One team brings it in, all of you suddenly have to take that on, even though one team needed it. And maybe that had a great reason to need it, but everyone else's deploys are slower. And with a micro front end, you only use the dependencies that you need. You only build the ones that you need, and you only deploy the ones that you need. So there's trade-offs, absolutely. And all the ones on the left aren't necessarily bad, and the ones on the right good. I think it's good to acknowledge that there's a quality to them. So here's the summary of some of the options available today. And this is not an exhaustive list, just the ones that I've been familiar with. I'd separate them into 2 categories. You roll your own, meaning your team, your organization makes their own micro front end framework. So the one at the top is the one I have the most experience with, which is in a React project, splitting it into more than one project, but still rendering on the same page. And I'll cover that in depth in the later part of this presentation. Another common one is using the JavaScript feature of dynamic import, using a manifest.json file. The next slide has an example of that. This is where you deploy your application, and it has a manifest.json file that says, here are my bundles, here are my chunks of my bundles. I'm going to be talking about Webpack a lot, so I'll mention Webpack chunks. And you're dynamically importing them at runtime, so it's only when the user needs to go to that a profile view or the article view that you pull in and process that code. And you might be familiar with something like React Lazy, React Suspense to actually enable that and have a good user experience around that. And the last roll your own example I've got is Webpack externals. That's actually a really interesting feature of Webpack, where you can include, let's say, I think in the link I've got here, it's jQuery. You can include a script that adds a jQuery global. And then in your Webpack externals, you define that if I import jQuery, don't actually bundle it, it exists in the browser. So just assume that it exists right there, and we don't have to make it a part of this application, but it doesn't have to be a library like jQuery. It could be another application that your team has built or another team has built. And then the second category of specialized frameworks, one's called Pyrrole, one's called Luigi. These are both frameworks that have, I'll call it that they're opinionated. They might consider themselves unopinionated, but it comes down to that last bullet. What kinds of languages and standards do you want to dictate? I think the specialized frameworks probably are the most confined, because they want you to develop your micro front end in a very specific way. And maybe some of them are a little loosely defined, but so they define that process versus rolling your own. You can say, what do we expect to need? What do we expect the multi-year trajectory of our team to need as far as tooling, supporting different frameworks? And then maybe for rolling your own, you can keep that agility about making decisions about technology that you use. So I mentioned that the manifest JSON example, this is the talk that would be good to watch, independent deployment of the front end. So it mentions Docker and Kubernetes. That's not necessary, but it's a good example of it. And this one uses the manifest example to look into, fetch that remotely, fetch a node fragment or a JavaScript fragment, bring it in, and then say, what do I need to import? What script tags do I need to create? And while that's happening, how do I show the user that we're loading? So this is a pretty good example. It's not what I've used the most, but I think it works really well. My experience, my personal experience, is on 2 different teams at 2 different companies, and these projects spanned multiple years. They were both internal projects, but held a high quality standard, a high standard on a high standard of user interface, reliability, performance, that kind of thing. So I consider them equivalent to a publicly facing application. We created our microfrontend systems in-house. So the first project was locally developed and deployed in virtual machines and later on Docker containers, but it was tightly scoped to like, this is what we've prescribed. And so it coordinated CI/CD and it used templates to define how you develop locally, and it ran in the cloud. And then the more recent project at Carvana, I decided that I wanted to provide the flexibility for teams to locally develop with any tool. So anything that can run React, anything, if you want to create it with Create React App or some of Carvana's internal tools, and if you want to deploy it to AWS or Google Cloud or some part of Azure or virtual machine, I didn't want to prescribe that. So I kept that flexibility open, which creates more opportunity, but also makes it a little more complicated. And it also runs in the cloud on Azure. So some of the problems that I ran into with Project B that I just mentioned, a pretty surface level problem that you run into first is how do you even render 2 different React applications on the same page? It's not div ID root anymore, React dom.render root. You actually have to have a place for application A and application B. If you have 2, maybe you have more. Each application needs that place to render. And in React, there's a couple different ways to do this, but we went with a small DOM structure that lives in the index.html. So that shot in the bottom left is actually in the public index.html file. And we're no longer rendering to that root, the element with the root ID. On the bottom right there, you can see we're creating a React DOM portal that renders to shell navbar. You can see that one in the bottom left. And so all of these divs with IDs have shell sidebar, shell navbar, body. Those are all different DOM elements, DOM nodes that can be rendered by an application. So application A renders into the sidebar navbar, application B renders into the body. And it doesn't necessarily have to be a parent-child hierarchy where you need to only render in one part of the page. React DOM portal can actually render in multiple parts of the application. Another problem we ran into was needing predictable Webpack output. We had to know what the file names were for different bundles. So we have a shell application we have consuming applications, and they have to know where the shell application's bundle is. And if you've deployed a React application, or an application using Webpack, you may be familiar with the hashing that goes into that, something like bundle.abc123.js. That's not predictable because the next deploy might be XYZ456. So we found a couple features in Webpack that let us have consistent file names. So there's a Webpack setting for output file name and a Webpack setting for chunk file names. But also we want to make sure that those aren't cached, because one of the reasons that the hashes happen is because we want to message to the browser, you need to fetch this file again. Bundle.js, the browser is going to think that that bundle was the same yesterday that it is today. So the hash is added, but we used Nginx to set no cache HTTP headers for the entire application. So for certain files, we can say these aren't cached, and you just have to have a quick responding server. So in our case, Nginx running on a Docker container, just hosting static files is a very quick solution to that. Another problem we had was application or libraries that we use on the page that don't interact well when there's more than one happening. So we aren't running Webpack, but Webpack is building the application, and there's a setting that's actually a global you can look at today in a Webpack bundle output that is a JSON-P function, and it's called, I think, Webpack JSON-P. And if you have 2 different applications that were both built with Webpack and you have them both on the same page, application A will render, and then a second later, application B will have downloaded and it'll overwrite. So even though you have 2 segmented pages on segmented parts of the page, 2 different React DOM IDs to render React into, you'll lose that first application, but you can use a Webpack setting to override that, output JSON-P function. And same thing with style components. There's probably other libraries that have both this problem, but also a solution for it. Style components doesn't work well on one page with 2 instances of it, and even outputs a console log error about that you may have seen before. But there is a process environment variable SC attribute that you can say application A, application B. Don't worry about interacting between them. And there's a few useful tools that I'll recommend for a micro front end. So I think create portal is actually one way that this becomes a lot simpler. We can create a portal in the page like I described earlier, and this is fully supported by React DOM. It's well documented. It's not some magic that you should worry about breaking. If they deprecate it, maybe, but I haven't seen that warning. There's also probably a good knowledge of Webpack configuration. I mentioned whatever bundler you're using. I mentioned that whatever we're bundling our React into, we have to understand how it works because there's custom settings for a lot of these things that we need to be knowledgeable of. And then I'd also recommend having an existing component library, because these micro front-end applications are independent applications. If you have shared styles, shared application or API calls or services, you need to have one place of putting them so you don't have 2 different versions in 2 applications and a bug is fixed in one and not in the other. We actually at Carvana went the micro front end first, and now we're doing a component library to get those benefits. And then I'd also say a useful tool is just adhering to React best practices, not trying to use the way you used to render an application using jQuery, even though you could easily pull in jQuery. That's not the way that React wants you to work. Follow the best practices and don't work globally if you can avoid it. So I think I have 3 or 4 lessons here that I wanted to talk about. One was we have some unexpected results with the micro front end. One thing that we actually didn't predict is because we have the shell application and any micro front end application inside of it, even if those were one application the day before we launched this, that has to be bigger at the end. It's not 50% and 50% or 90 and 10. It's going to be like 70% of the application and then 50% of the application. It's naturally going to be larger. If nothing else, you're bundling a new React and new style components, all these things. You're duplicating effort on the page. And we thought that might negatively impact load time. And while it does, actually, the smaller of the 2 applications renders on the page first. So the user perception is that they're seeing a part of the page before they see the rest of it, as opposed to all of it rendering at once. So whatever you have, I would recommend the shell, whatever is common, should actually have a fast load time, should be lightweight, because then actually the user perceives they're seeing a better performance, even though they're actually not. Also, we noticed that unnecessary cross dependencies were obvious immediately. You can use static analysis tools like ESLint, Webpack Bundle Analyzer to show where you're spending a lot of the bytes, and also if you're even using them. So we were actually able to prune the package JSON dependencies on a lot of these projects to a fraction of what they were before. Our team structure actually surprisingly shifted to align with the micro front end design. We actually launched a new team whose mandate is to work on things like these shared dependencies, like the component library. And I thought that was a pretty interesting change. And then also there were some teams that shared our build pipeline that improved theirs, and then they showed it to us, and we took their improvements in the pipeline because we were able to say we don't just have one pipeline. Everybody can make their build however they want, and we can pick and choose what's the best ideas from a more diverse ecosystem of builds. And the last part I like a lot. We could be lazy when we need to. If we're deploying every day, but our team has nothing to deploy this week, we don't have to be involved in any deploys, right? If we go a week that too much of the team is out on PTO, we actually don't have anything sent out, we don't have to be bothered by a deploy because our application, our micro front end, or multiple micro front ends aren't changing. So that monolithic deployment, that coordination across teams, so that you can be lazy when you need to. Another good lesson is about how micro is too micro for these front ends. I'd recommend 3 different ideas, and there's probably more, about the seams to separate your front ends when you're doing a micro front end. One is maybe think about the cohorts of users. Which users are going to be using application A, B, or C? You could separate based off of those so that application A is developed independently, and you can help user group A. You can help user group B and C independently. You don't have to worry about one team servicing multiple cohorts of users. Similarly, talk about team owner. Your team doesn't own a group of users, but you own, let's say on Twitter, the profile experience. How do we make the profile experience best, or the home experience? You have a way of separating that, and you own that entire application. I'd say the biggest recommendation is don't just think about it with navigational hierarchy. Don't just look at the URL bar and say, we own /presentation, we own /profile, because that may be the actual team ownership, and that may just be an easy way of substituting not thinking about it hard enough, because navigational hierarchy may not actually line up across teams and across applications. And a recommendation about high micro is 2 micro, you shouldn't need to coordinate between 2 different micro front ends often. You may need to from time to time. How do we hand off parameters between applications? But that shouldn't be the common week-to-week, day-to-day behavior. You should be able to go weeks, months without having to have that coordination. And the coordinating element should have common concerns. So that shell that I'm talking about, it should control things like auth, maybe common settings, feature flag, maybe site-wide search. So that shouldn't be a single search application. If you have something like Amazon, right, where you can search for products, you can search your order history, search may be something that is actually handled in one place, and you have services within that shell application that handle those common concerns. A few more recommendations. I'd say a micro front end should only be done when you anticipate problems and growing. You shouldn't put small applications. You shouldn't start that with a micro front end, because they may have a shelf life, right? They may not be touched for a while. And a strategy that starts with that micro front end risks wasting that on-ramping work. If adoption is slow, your solution is incorrect, you've wasted time. An application shouldn't, I mentioned already, short-lived, but I'd use it for projects that you know are going to have a multi-year time span, and enforcing that and making sure that like this is not just for this quarter or for this year. We expect to be using this and building it and improving it for years to come. And a good micro front end won't fix a bad application. So don't try to see it as a band-aid that'll fix anything that is underperforming. The last recommendation is that React cooperates really well with a micro front end. There's actually 2 different efforts like that going on Carvana, and we've done 2 different implementations, and we've also learned from each other, but both are using React, both are using Webpack. There's some common concerns there that I think are working really well. And that's what I've got. There's my social handles, and I'll look at the comments and see if there's any questions. Thank you.
Thank you, Pablo. Very interesting topic. I've been very excited about Microfrontends since I heard them the first time. So let's look at the comments. If anybody looking at this right now has any questions, take this chance to drop a comment, or you can also reach out to Pablo through his social networks. If we don't see any comment, we can go to the next speaker.
Thank you.
Thank you. So let's bring Erik. Bye, Pablo. There we go. So I'll leave it up to you, Erik.
Okay, hello. My name is Erik Rasmussen. You may know me on GitHub or Twitter, where I look a little bit more like this. And today I'm here to talk to you about everyone's favorite part of web development, forms, specifically forms in React. And to understand building forms in React, you need to understand the difference between controlled versus uncontrolled inputs. Now, the important thing about what makes an input controlled or not is whether or not you pass a value prop. So the input on the left, the React is going to let the DOM input manage that input's value, and you can type freely into it. But for the input on the right, React is going to make certain that the value will never change. It's always going to render with exactly that, whatever string you give to the value prop. So no matter how hard you bang on the keyboard, you're not going to be able to change that value. And this means that we as developers have to do the hard work of maintaining that input value and watching it change. So what this looks like is something like this. This is about as simple of a component you can have with a controlled input in React. We're going to use a useState hook, and that's going to give us a value and a set value. We're going to give that value to our input, and then we're going to add an onChange handler that is going to take the React synthetic event and call and get the value out of it from event.target.value and call set value, which is going to then re-render our entire component. Pretty easy, right? There's only 2 lines here, really, but there's already a bug in our component here. I'll give you a second to see if you can spot it. The problem is that we're not specifying an initial value in our use state. So our value is going to start out as undefined, which is going to leave our input uncontrolled. And in development mode, React is going to give us a console warning saying, hey, this input went from uncontrolled to controlled. There's probably a bug here. You probably didn't mean to do this. And sure enough, we didn't. But it's an easy enough fix. All we have to do is provide an initial value of an empty string. Now, the React docs don't really give much guidance beyond this point. They will tell you how to make a controlled inputs like this. And like if Facebook had come out and provided a recommended structure of how to build forms with more than one input, it could have saved us all a lot of time. But they didn't. They just sort of said, let the community figure it out. And I have a little pet theory about this. I don't know how true it is, but I think it's kind of funny. If you think about it, how many inputs does Facebook typically have on their big flagship product that's used by hundreds of millions of people every single day? They've just got the one input, right? This is probably the most used form on the whole internet, between that and Twitter and all of our social networks. Really, there's only one field. But that doesn't help us building enterprise applications where we need to be letting our users more or less edit database records, right? And if you think about it, you can imagine using our little use state thing, and we could duplicate that 5 times for our 5 different inputs that we had. And for a small form, like a login form, for example, you can imagine adding some pretty easy validation, and you could manage all that yourself using the use state hooks or use reducer or something like that. But if you have a bigger form, the complexity can really add up quickly. There's a lot of form state. So I want to talk briefly about what I mean by form state. So obviously with form states, you've got to maintain the values of your fields, right? Like we've discussed, to make your inputs controlled. But then if you've got some client-side validation, you need to know whether or not your field is invalid or invalid, or if your whole form as a whole is valid or invalid. And then there's things like dirty and pristine. Maybe if dirty being have the values changed since it was loaded, and pristine is the opposite. So like maybe if the user doesn't change the values, we don't need to send it. We don't need to send it back to the server when they hit save or something, for example. And if you got validation, you got validation errors, and some of those will apply to the whole form itself, and others will be field specific. And then you might want to keep track of which field is currently active. Maybe you want to show a little tooltip or something to help the user figure out what sort of information they need to put into that field. And then you might want to track which fields has the user been to, and that's what I call visited. And touched means the user's focused on the field and then left the field. That can be really useful for displaying error messages, for example. And then maybe you want to know which fields have been modified, whether or not even if they have been reverted back to their pristine values. And of course, now that we submit everything with Ajax, you need to know if you're currently submitting, and if your submit has succeeded or if it has failed, or and of course, what are your submit errors? Again, are they field specific or are they general to the whole form, like login failed or something like that? And then maybe you want to, when the user's trying to fix these submit errors, maybe you want to remove the error if they've had an attempt to fix. So you want to keep track of whether or not the fields have changed since it was last submit was attempted. So when I talk about form states, this is what I'm talking about. That it's all of this stuff that in a real enterprise application, you're going to need to keep track of all of this somehow. And if you can, imagine for a moment how you would do this with the React useState hook, for example. It could get pretty complicated pretty quickly. Now, remember how I said that Facebook really sort of let the community work out how to manage form state in React? Well, the first major form library that got popular in React was one that I wrote called REDUX Form. And to this day, REDUX Form is one of the most downloaded form libraries in the React community, with about 2 million downloads every month. And in my years of maintaining REDUX Form, the community and I really came to the conclusion that global application state is probably not the best place to keep your form values in your form state. Because you've got to, for many reasons, but for one, when you're dispatching an action on every single key press, Redux has to go and check with all of the reducers in your system to see if they care about those actions, and it's just not efficient. It's not the right way. And of course, having such a popular library, I received a lot of feedback, and I'd like to go over a little bit of that feedback with you now. The first big one was, what do you mean it's only for React? People use Redux with Angular and other frameworks. Why is it only for React? And then, like, why should I have to install this global application management system just to maintain some form state on one of my forms, right? And another one was, why do parts of my forms have to re-render even though I don't care about, like, I'm not modifying anything when that particular part of form state changes. It'd be nicer if I could tell it not to do that, right? And the big one is literally the big one, that it's a big library. Over the years of having people come to me with edge cases and say, hey, can we make it do this? Here's a PR. I've implemented it, so now it'll support my use case. And saying yes to all of those things made the library in itself grow to such a degree that it's really just very large. And like, it doesn't make sense for, say you have a small form, like a login form or something. It doesn't make sense to force your user to download all of this extra code that's made for managing, arrays of fields and complicated field structures just for a tiny little flat form. But with the way the bundling works, that's what happens with Redux Form. So I thought there must be a better way. And so I took all this feedback and I sort of started from scratch. I erased the whiteboard and I said, okay, what would the perfect form library look like? What if it could be pure JavaScript? No dependencies on Lodash or some other data structure library. And what if it could be framework agnostic? Because if you think about it, all that stuff that I called form state, none of that is React specific. That's true of managing form states if you're using Angular, Vue, or whatever. Or whatever the future library that we're all going to use after React. You're still going to need to manage all of that kind of state, right? And what if it could be like subscription based? What if it could be like with GraphQL, for example, you can specify these are the few bits of fields of state that I care about and only give me this. So you don't have to with GraphQL, it's saving bytes downloaded from the server. And what if you could specify exactly which parts of the form state you wanted to be notified about? And what if it could be modular, where different bits of functionality could be added onto the base core module as you needed them? So you didn't have to download all the possible use cases at once? What if you could start with a core thing, and then if as your needs got more complicated, you could add bits and pieces on? So after thinking long and hard about this, the solution I came up with, I called Final Form. And Final Form is a standalone form state management engine. It is totally framework agnostic. It's subscription based, where you subscribe to parts of the form state that you want your a callback to be notified about. It's got plugin capabilities where you can add on extra functionality as you need it when you need it. It's got 0 dependencies, and it weighs in at 5.2K gzipped. And although Final Form itself is framework agnostic, I, its author, do have a favorite front-end framework. So I've also written React Final Form. And React Final Form is just a thin wrapper around the Final Form core with bindings to React to map form and field state to render props. It knows how to handle React synthetic events. And because it's so thin, it's even smaller at only 3.3K gzipped. So together, they form a total React form solution of 8.5K gzipped. So you might be wondering, how does that compare to other libraries? Well, good news, I've done that research for you. And it looks a little something like this. Not only is React Final Form smaller, but it even has some other additional features that that some of the bigger libraries don't, such as tracking which field is active and things like that. So if bundle size is important to you, and I think for the sake of your users, it probably should be, I would strongly consider that you choose React Final Form for your next project, or even migrating it from whatever you're currently using. There are 2 migration guides from the big form libraries that can be found at these addresses. And don't be afraid, it's really easy to migrate because both Formic and React Final Form copied so much of their API from REDUX form that they're really all quite similar. So let's look quickly at the React Final Form API. It consists of 3 primary components. There's form, which wraps the entire form and provides form state to a render prop. There's field, which registers a field and provides field state and callback functions to a render prop. The callback functions being things like onChange and onBlur and onFocus that you would need to give to your input to hook it up to React Final Form. And the third one is kind of a mysterious one called FormSpy. FormSpy provides a way to read form state from within your form without re-rendering the entire form. And that's a pretty complicated sentence, and I hope it will make sense by the end of my presentation. But this talk is called Modern Form Development. So we also have some hooks. We've got useField, which provides all the values that field would inject via render props. We've got useFormState, which provides all the values that FormSpy or form itself would inject via render props. And then we've got useForm, which provides access to the underlying Final Form instance that you can call imperative things on it if you need to. So I think it might be time to see this in action. So we're going to try a little live coding. Let's see how this goes. Okay, so I don't have time to build a form entirely from scratch, but the APIs of most of the form libraries that use render props looks something like this, where you've got your form out here that you pass in an onSubmit thing. In this case, I've got a function that is going to alert the values. And that's given via render props a handle submit function that is just gets passed directly to the HTML onSubmit, and that's going to know not to submit the form if there are validation errors. And we're getting our form values and a Boolean about whether or not we're currently submitting. And then inside here, we've got 3 fields. These are all identical. The fields component provides via a render prop 2 main things. This input is all of the props that we need to give to our input component, like name and value and on change and on blur and on focus. And that's made for your convenience, where you can just spread those out. And also we've got meta, which provides our error and whether or not we've focused and blurred the field, and that prints out our error. So we've got 3 of these. And then down here for our submit button, we're disabling it when we're currently submitting. And for demo purposes, we are printing out here our form values so we can see them change as we type. So let's see what this looks like. I can type into my form. These are controlled inputs, and when if I have an error, if I blur a field that I need to fill out, it forces me to go back and fill it out. And then when I hit submit, it alerts my values. Okay. So what I want to show you is what makes React Final Form special compared to other form libraries. And that is this ability to control re-renders of different parts of your form. So I've got this thing called render count. It just prints out how many times it itself has been rendered. So let's throw some of these guys in here. Field. And then we're going to put one down here that are pre. Okay, so now we have these little counts here. This is how many times the whole form is rendered, and there's a count for each field, and then there's a count for our values down here. Okay, so as I type into my form, notice when I gave focus to that field, the currently active field changed, so the whole form re-rendered. And as I type, on every single key press, the whole form is re-rendering and all of its inputs. So when the form re-renders, each input has to re-render. So this is perfectly fine for a small form like this. This is for up to 20 or 30 fields, you don't need to worry about this sort of optimization. But I have users of my libraries that have 300 and 500 fields, God help them. And if you have that many fields, then all this rendering can be a performance problem. So let's look at how we can control these re-renders. On our form, we've got a subscription prop. And here, sort of like, I don't know if you have worked with MongoDB or GraphQL, where you specify the bits the part of state that you want to be informed about. This is where you put. This is an object of Booleans. So, for example, we care about values, and submitting are the 2 bits of form state that we care about. And we do the same thing here for our fields. So subscription, we can see here we care about error and touched. And although it's not really obvious because it's hidden inside here, we obviously need to know about our value changing. So let's copy this guy for all of our fields.
Excuse me, Eric, pardon my interruption. Could you please increase your volume, please? I see some comments from people that for some reason
Okay,
just
is this better?
Loud and clear on my end. Can someone on the comments say now it's better?
Sorry about that.
Don't worry about it. Make sure we got it covered. So if there's still audio issues, just let us know, and we will just increase it. I'm gonna leave it to you back. Sorry, Mary.
Okay, sorry. Thank you for that interruption. So now we've added these controls where our form is only going to re-render when these things change, and our fields are only going to re-render when these things change. So now watch what happens. When I focus on this field, nobody cares about which field is active anymore, so the whole form isn't re-rendering. Then as I type, watch what happens. So still, every time I hit a key, the whole form is re-rendering. And that's because down here we're putting out our values. And for our values, anytime we hit a key, our values change, right? So it's re-rendering the whole form. And that means that we can't subscribe to our values here. We have to remove that. Now when we type, look at this. Only the field that we are typing in changes. And then when we blur, it's going to re-render again because touched becomes true. And we're listening to touch to show our error. So here, like if I blur, if I come off of this, it had to re-render to display the error. But we lost our values down here. So somehow we need a way to get some form state from within our form without re-rendering the entire form. And as you may recall, that was what FormSpy does. So we take FormSpy and we come down here to the bottom. Surround this guy. We say FormSpy description. We care about values. And here we're going to get our values and render out our pre here with our values. So now we have our values. And now when I type into here, look at that. The whole form is only rendered once. Each field is only rendering the minimum amount of times it needs to render to be a controlled component and to show errors. And this guy down here is re-rendering as often as it needs to get our values. So this is an example of if you had 100 fields, this would be an important thing, an important level of control. So again, the reason it defaults to re-rendering on every possible state change is because that should be the default. That's what is most common and most needed. But it's good to have this level of performance control when you need it. Let me quickly look through if there are any questions. Okay. So that's all we have time for with the live coding. I hope you enjoyed that and learned something. Let's go back to our presentation. So we did not fall off the rope. I want to talk briefly to finish up with how and when to choose a library, not just a form library, but any sort of library. It's important to consider how complicated the problem is that you're trying to solve. If you just need a button that changes color or a simple 2-input login form, you can probably handle all those state changes yourself. But if you need a complicated calendar widget or a large registration form with complicated validation rules, you might be better off looking for a pre-made battle-tested solution on NPM that's been well tested. Also, how extensive, hold on, my Siri is talking to me. Be quiet, Siri. How extensible is your does the library look? Is it does it look like it's going to be able to grow as your complexity inevitably grows with your project? And one good way to see how extensible a project is to look at the examples provided. There are many things that I love about Next.js, the front-end framework, the web framework, but one of them is their really huge examples directory on the repo for any possible companion technology that you can imagine, like Node web servers or CSS and JS libraries or state management libraries. They have an example of how to use that with their system. And similarly, Rack Final Form has over 40 different examples. These are all things that I, because I knew all the different use cases that all the users of Redux form needed in their form libraries, I was able to build up this really detailed examples library of all the possible use cases that you're probably going to run into. So chances are whatever you need to do with forms, React Final Form can handle it. And as I mentioned before, bundle size is not everything, but if you're more or less between two libraries, it's a good metric to pick one over the other. And notice I'm not saying anything about GitHub stars or npm downloads. In my experience, the older the library is, the more of these they tend to have, and there can be newer libraries that do things in a better way that aren't as well used because they're just newer. So I would not put a lot of stock in those values when choosing a library. And finally, just does the library make sense to you? Does it comport with your way of thinking about problems? And before I leave you today, I'd like to tell you about a project that I've started where a lot of times when we're building UI, we build a thing and it seems really obvious to us how it should be used. And then we give it to a user and they go and click on stuff that you wouldn't ever imagine them clicking on, and they don't really they get confused. And what seems obvious to us, the creators, is sometimes not obvious to the end user. And so when it comes to forms, wouldn't it be nice to know how users are using your form? For example, we know when someone submits our form and we get data back into our backend, we know that someone has submitted our form, right? But how many people started filling out the form and then left? There's not a lot of, very few people are looking into that level of form analytics and how, maybe there's a certain field that confuses 20% of the people that would otherwise have continued to fill out our sign up form, and we just lose those conversions. So, which field is causing the user to abandon the form? Also, how long do they spend on each field? Maybe there's one field that isn't really all that important to us on a business level, but it's taking the user a really long time to fill out and might be slowing down our conversions. And how long does it take a user to get to a particular field in our form, our most important field that we most care about? Maybe we should put that more at the top, or it'd be nice if we could know how users are using our forms like this. And so after thinking about this problem, I've built a tool to provide some insights into these metrics and to help you build better, more efficient forms, which ultimately leads to more conversions and more money for your business, right? That's what when we build a form, our goal is to have the user actually fill it out and submit it. Anyway, I call this service Form Nerd, and it provides analytics like how many starts versus submissions happen with your form over time. What are the conversion rates? If you make it, because you can see it over time. If you make a change, you can see how that affects your conversion rate. And it also has over 20 different metrics for each field in your form, so you can get a detailed view of exactly which fields on your form are causing the most trouble for your users. So anyway, that's my project called Form Nerd. It's currently in private beta, and but you can sign up now at formnerd.co to be notified when we launch, which should be in a month or two. This whole virus thing is slowing things down, but it should be public soon. And you can DM me on Twitter if you'd like to participate in the private beta. And thank you very much.
Thank you, Eric. I see a lot of good feedback on your presentation. I'm gonna bring Pablo in. So, okay, so I know that there are a few questions for Pablo. Do you want to first answer the one you got here, Eric, and then we jump to Pablo, so we stick the same?
Sure.
So this is the only question I see so far. By the way, how did you handle accessibility on the forms?
Good question. There's React Final Form doesn't deal a lot with the accessibility aspect. That's more of a because you're in charge of rendering the inputs. You can use as many accessibility features as you'd like. There is a plugin for Final Form that will use HTML5 validation the standard. So it will use you can show errors using the browser's way of showing errors, which is I haven't spoken to an accessibility expert, but it must be more accessible for screen readers and stuff if you're using the standard. So again, it's up to you, the user. There's nothing specific to managing how the form state flows that relates to accessibility.
Cool. We got a second question also by Marcos. Is it possible to navigate via tabs? Does it set area properties and makes titles possible? So also related to accessibility.
That's the same question, really. You're in charge of how you're rendering the form. All Final Form is doing is giving you your on change, your on blur, and your on focus callbacks to keep track of which fields are currently active. How you render them is up to you.
Excellent. I think that's all we got on your presentation, Eric. Thank you very much. It was really awesome. Even another React developer, I understood your demo, so that's quite interesting. So
I think there are because Final Form is framework agnostic. There are people that have written wrappers for Vue and web components. And I've heard talk of some Angular stuff, but Angular is so opinionated already on how it does forms. It's sort of hard to get purchased in that community. But there are some other front-end frameworks that are using Final Form under the hood, which is cool.
So let's go to Pablo's questions. So I'm going to bring up the first question from Sebastian. Can I use something like this to allow a customer of my web app to add their own small slice of custom code specific to his business, which appears as a tab in my app?
Yeah, that is definitely possible. I would definitely caution against the security implications. I would audit, how they're doing their development, maybe even gate deployment based off of some analysis. But yes, you could allow some third party, as long as they play well within the system, to also deploy this. The system I use in Project B that I went in depth in my presentation, it doesn't really dictate the source, the deployment. It could be on a CDN, it could be in a virtual machine, it could be in any sort of system. So you definitely should go towards a system that leaves that flexibility, but I'd also be careful about the security concerns.
Excellent. We have here another question from Nick Button. When refactoring an existing large app into Microfrontends, what were the roadblocks or bottlenecks that cost you a lot of time or were hard to solve internally?
That's a really good question, Nick. I'd say the biggest roadblock and bottleneck that I experienced was a personal one, and this is where the talk came out of that, which was being able to sell the solution or the problem and then the solution to that problem to the stakeholders, not only leaders, but developers. When it came down to it, I'd say I probably did 80% of the work, and I'm not trying to, take credit for things I didn't do. I'd say I had to lean on my own resources and make time for it because it was difficult to define the systems thinking that was involved in that, right? So basically salesmanship, marketing skills, and I don't mean like externally, just you go over to a developer and explain the problem and explain your solution, and it's very difficult without being in the weeds to handle that. But I'd say that's probably the biggest one. When we've launched it a couple months ago at this point, and it's been running well. Now that it's in flight, I think it's a little more understandable and a little more clear what the purpose was. And also, I'd say there are decisions that could have been made better if there had been more people involved. So that is a risk and also an opportunity. If you can justify it to other people, you can get more opinions on how it can be done best.
Excellent. I hope that answers your question, Nick. I think we don't have any more questions. Thank you both for your time, for being here, for doing these talks. And remember that you or any of the people that's watching us right now, if they want to give a talk here, we're always open for new speakers. We're trying to be a global community and helping each other. So also, if you have any more questions and you feel more comfortable talking privately, you can also send a DM to Pablo or to Eric, and I'm sure they will do their best to help you. Thank you everybody for sitting to this session. I want to remind everybody to thank especially this DOT for sponsoring this event, for giving us this space where we can chat and learn more about different technologies. And just to remind you, we don't only do React, we also do Angular, Vue, RxJS, GraphQL. And if you have something else that you want to learn, just reach us out, and we're here trying to build a stronger community. Thank you everybody, and have a nice day.
Thank you.